of document similarity measures. Actually, most of these similarity measures come from data mining, and we apply those similarity measures with text documents. The problem is, this is also a new research area. Use of these similarity measures in text is also a research area, because in data mining we treat data as a point without information, but in text every word may have a different level of importance. So these all similarity measures considers word or term in a document as a data point. Still these similarity measures work well, but is it significant to use those type of similarity measures with text documents? Now, because it will be like working with less amount of information. Means text documents, every word may have a different level of importance. If you treat all words as equal importance, then it may be like you are working with less amount of information. So applying these similarity measures generally creates such problems, and this is also a research area, that how can you utilize the feature which are available in text documents with different type of similarity measures. Here I will just introduce about different similarity measures, and these similarity measures are very useful whether you cluster the documents, classify the documents, or suppose you have to search any documents and you want to apply some query, then by using similarity measures you can identify the relevant documents. So these similarity measures are very useful. Now the similarity measures, I will cover two type of similarity measures. Similarity measures between two documents, or similarity measures but between document versus query terms. Similarity measures can also be used to rank the documents. For example, suppose you want any document, suppose you have a set of documents and you want to rank the documents in that set based on similarity with respect to some topic, some given query, then you can use these similarity measures to rank them. Now the issues are presence of a large number of similarity measures, and this is also a problem because the base known similarity measures are still, you cannot decide that this is the best similarity measure or this is the worst. It depends upon the applications. Now the simplest one, similarity measures, precision recall based measure. Suppose A represents the relevant part and retrieved part, and B represents the relevant part. Now how can you identify the relevant and retrieved? I will go through some simple example. Suppose you know the key phrase extraction. In a text there is a key phrase extraction. You know the key phrase extraction techniques. Actually, document contains some important terms. Those terms may be a single word or maybe a sequence of words, and those small set of words generally represents the basic theme of document. You can say that it represents the condensed summary of document. Such types of words are known as keywords for documents. Keyword extraction is also a very interesting research area. Still there are a lot of papers available on key phrase extraction, but accuracy is around 30 to 40%. And key phrase are very useful for different tasks like summarization, document indexing, etc. So now suppose for any given document document D, we have manual annotated key phrases like K1, K2, K3, K4 and K5, and a machine generated key phrases which are like K1, K7, K8, K4 and K5. Now you can identify that this is our retrieved part A and these are the relevant part B. Now which are the common? So these common parts will go through here. Now it is clear. Now how precisions can be calculated? Precision is equal to relevant documents. Here it is relevant keyword divided by total retrieved documents. So suppose here A intersection B is equal to 3 divided by mod of A is 5. Now suppose here we extract some more keyword like 10, K12 etc. So recall will be 3 divided by 7 because counting of this part is total 7. So this is a simple criteria to calculate precision and recall, and this is the basic measure. Even to identify the accuracy of key phrase extraction algorithm, precision recall measure and F measure is the best known algorithm, best known similarity measure to calculate the accuracy of key phrase extraction, and this is a F measure. F measure can be calculated by 2 into precision into recall divided by precision plus recall. Now you can identify the precision and recall with given example below here. Now suppose you know the document summarization. You don't know document summarization? You know the latest tool Samli. If you read the newspaper, then you may know that Yahoo Research purchased one English means one student living in Britain developed one mobile app which is related to summarization of news article, and Yahoo Research purchased that tool by giving millions of dollars, and they offered job that person also. So if you know the summarization, means if you are aware of current news, then you may know the importance of this field. Suppose most of the people using iPhone, and it is not possible now these days, it is not possible to read the entire news article at a time. So they first try to look out the summary of news, and based on the interest they go in detail. So summarization is a process in which machine generates, especially in computer related document summarization, machine generates the summary for given document. The document may be news article or any text. There are a lot of different summarization methods are available. Even summarization methods are helpful for research also. Suppose you have a different scientific articles on same area, and you want to know the research progress of entire research area, entire collection of documents. Then by using summarization, you can get the research summary, research progress summary for that collection of research papers, and it will reduce your time also. Now to calculate the accuracy of summarization, we also use precision recall and F-measure based techniques. For example, there is a human annotated sentences. Suppose a human judge extracts 4-5 important sentence from a document as a summary. Machine extracts 4-5 sentence as a summary. Then based on the word matching, they calculate the same, they apply the same method to calculate the accuracy of summarization. So this technique is also useful for evaluation of summarization. Now dice coefficient, you already know the dice coefficient. It is a harmonic mean of precision and recall. So if you just extend the value behind the precision and recall, then you will get this formula: 2 into A intersection B divided by mod A plus mod B from this slide. This is precision, this is precision and this is recall. And this is a simple trick how to calculate the harmonic mean of the numbers. So dice coefficient is also used to calculate the similarity between documents, two documents. Suppose you have given documents D1 and D2, you can use those similarity measures to develop a very simple applications. Like generally people submit similar kind of assignments. By using such kind of similarity measures, you can identify the overlapping words and identify the percentage similarity between answers. Now this is an extension of dice coefficients. How can we extend the dice coefficient? Means this is just for some special case. If you want some depth calculation, you want that precision, we should give more importance to precision, we should give more importance to recall, then we can modify. Actually, especially in vision or in some complex text mining applications where precision plays very important role, means precision is very good, then you can consider that system is reliable, or recall is very good, then system is reliable. Then we can use such kind of modifications with those systems. But in case if you give equal importance, means alpha is equal to 0.5, then it will give you a simple dice coefficient here. So this is just difference of importance. If you give different importance, then you will get different result. If different importance, then different results. Now you should know the meaning of this. What is the meaning of this part? Actually, K means, suppose there are words like document D1 contains word 0 2 times, word W1 1 times, word W3 4 times. Document D2 contains word 0 times, word 1 3 times, word 3 2 times, and so on. And even it contains, these are the common words. So K is equal to 1, you will get this part. So this will represent the occurrence frequency of this, and this will represent the occurrence frequency of this for common words. And here also this is similar to this, and this is similar to this. Okay. Now Jacquard coefficient. Jacquard coefficient is also similar to the dice coefficients, but slight different, very simple difference. Means it is a division of intersection of two sets by union of two sets. Actually, Jacquard correlation coefficients are also useful in calculation of Jacquard distance. means how similar or dissimilar two documents, or how the conceptual distance between two documents. If you want to know this kind of measure, then you can use Jaccard correlation coefficients, and this is the general measure technique, 1 minus Jaccard correlation coefficients. It will give you the distance, and suppose you have a query, then how can you use Jaccard correlation coefficients to calculate the similarity with respect to. For that, you can use this part, same as I discussed earlier. Suppose you have a query, for example here, this is a query here, and there are two documents, document D1 and D2. Now you have to calculate the Jaccard correlation coefficients for given query Q, means which documents are more relevant for given query. Then how can you calculate? By using Jaccard correlation coefficient. Now T1, T2 or T3 represents the terms, and number assigned before those terms represents their occurrence frequency. Now these are the query, means suppose this is similar to what you type on search engine. Generally on Google you type like social networking, then social word like T1 represents the social frequency 1, networking frequency 1, like that. So, and these are the documents in collection. So how can you calculate the Jaccard correlation coefficients? Now this part, for k is equal to 1, it will take first term of query and identify the similarity with documents. So what is the similarity? Here it will be 2 into 0 divided by, this is this part will be already 0 with respect to T1. Similarly, you can calculate with respect to T2, because here this part contains some information, like with the documents there are two terms. For this term minus this part, you will have 2 into 0, because for term T1, got this point, and just after summation you will get the similarity value as calculated here with respect to document D1 and with respect to document D2. Means so Jaccard correlation coefficients for given query Q with respect to document D2 is 0.4, and with respect to document D1 it is 0.31. This means document D1 is more similar for given query Q1. So this is also represents the ranking of documents with respect to any given query. Got it? You can easily analyze also this part. Thus you can use such kind of similarity measures to identify the similarity between documents or to rank the documents for both purpose. This is cosine similarity measures. Actually, cosine similarity measure is the most famous measure for document similarity. You can actually cosine similarity measures calculates the document similarity based on the cosine of angles between two documents. But how can you calculate? It is important. And the thing is, you may already know the nature of cosine curve. Like for 0 to 180 degree, it is a decreasing, monotonically decreasing curve. Means at 0 it starts with 1 and then 0 and then 1, and after 180 degree it will This is the general nature of cosine curve. Generally we use 0 to 1 part for similarity measures to calculate the similarity between documents or to rank for document ranking. So how can we calculate the similarity measure between given query Q and given document D2 and D1? Suppose we have two documents D1 and D2 and we have to calculate the similarity measures, means how those documents are relevant for given query Q, that we have to calculate. There are two methods. First and the simplest method is cosine similarity between two terms or two documents is just the product of square root of their precision and to recall. So most of the similarity measures are directly or indirectly related to precision and recall. So this is a general technique to calculate the cosine similarity, or you can use the traditional measure to calculate the cosine similarity. So cosine similarity between query Q and document Dj is the dot product between them divided by product of query Q and Dj. Now you can divide this part like that. You can extend this part like this. As I already explained that for any given document, suppose given query Q contains the term T1 plus and documents D1 then how can you calculate the cosine similarity between query Q and document D1? How to use this formula? For k is equal to 1, so we will start with first word of given query. So first word of given query, we know that the product of this part will be 0, so no need to take that. So we will take this part. For k is equal to 2, what are the words which coexist between, number of words which coexist between given query and document? So coexistence is here one word coexist, not both words. So here in this part we will use 1 divided by, for second term k is equal to 2, divided by kq. How many times it occurs? 2 times. And k is equal to 1 to n. How many times in documents it occurs? Only 1. So do you think that this looks similar to this part? And if you continue this for k is equal to 1, now for k is equal to 2, k is equal to 3, you will again calculate three times it co-occurs. So here you can add three square, and this part you can add. How many times it occurs in documents? 5 times. So 5 square. So you can add this part, and then multiply, and then take this. You will get the cosine similarity. Or if you don't want any complexity, then just go to precision recall based technique. Root under precision into recall. And expansion of that precision into recall is number of intersection words which are common, means frequency of that common part. you have to identify the sum of those parts, like 1 plus 3. So here A intersection B is equal to mod under 1 plus 3, and root under A into B will be like number of retrieved or number of relevant, you already know. Based on that you can calculate, because this part contains number of retrieved part and this part contains number of relevant part, and you have to take the sum of both and take square root. You can calculate the cosine similarity, or you want some light? I should go. If you don't want to take pressure, then I will go.
You want to take a break and do the math yourself? Do it. 5 minutes. Because it is just going in lecture mode. It's also not very clear where the synchronization point is. So it's good to actually try it. And if there's an issue, just ask. And then we have a synchronization point and we move on.
For hint, I had given the picture also. Okay, this is very simple. Now I will go through the asymmetric similarity. Okay. Okay, just calculate and check answer. Answer is given. Just calculate after that.